Welcome. My name is Professor Carl Schwarzenegger, and welcome to another lesson on how to use Excel. In today's lesson, we will build upon what we learned in the previous lesson in analyzing data, and we actually learned how to create a scatter chart and then look for some correlations and trends and possibly use those correlations to predict something. You might do this with field data in wildlife or any other scientific observation. But in business, we always try to forecast. So, for example, today's illustration, we have a local beer distributor who provides beer for a local baseball team, and they would like to do a better job of predicting what their sales might be on any given day. And you might think that, okay, sales will certainly be proportional to the number of people in attendance. Obviously, the more people that are at the ballpark observing the game, the more beer might be sold. However, since these games are sold out for the most part, it's not very good correlation. It's not a good predictor of what might be, what the daily sales might be. So we're going to have to look for something else that might help us. And so, in fact, we all know that as the weather gets very, very warm, we tend to get thirstier and we tend to drink more. So it would probably be a good argument to say that as the temperature rose, you might be selling more beer. And so what the supplier endeavored to do was to record the high temperatures over the past several weeks and then take a look at the sales during that time. And so here we have the data. So you can see over in this column we have the high temperature for the day, and in this column we have the beer sales whenever that on that particular day compared to that high temperature. And we'll take a look at the data and see what happens. Now, doing a scatter chart in Excel is relatively easy. The biggest problem you would have is actually setting up the data to import it. So you can see you have this data in a column format. One column has a temperature, and the other column has the corresponding sales for that particular day, for that particular high temperature. And the data does not need to be in any particular order. Excel will sort it out as it needs to. So very easily, all we have to do is highlight the data, including the column headings. So once we've got that highlighted, we go over to our insert ribbon and we move across to the charts, and we want to select a scatter chart. So we're going down and selecting a scatter chart without any lines, and so we click on that excuse me, and you get an immediate result. So there we have a scatter chart which kind of shows the on the x-axis the average, the high temperature for that day, and then on the y-axis the actual sales. And it appears to be pretty linearly correlated. It seems to be relatively linear. Let's move this chart to another worksheet. We've done that in the past. We need to right click on a border and we click move chart. Move chart. We're going to move the chart to a new worksheet, and we're going to call it beer sales. And so there we have it. We now have a new chart with the beer sales, and on the bottom we've got the average, or actually we have the high temperature for that day, and on the left, on the y-axis, we have the sales corresponding to that high temperature. Now we've got a lot of wasted space over here, and so we can make use of that by rearranging our chart, or actually modifying the x-axis. To do that, we right-click on the x-axis. You can see Format Axis. We select Format Axis, and you can see the x-axis has a lower minimum of 0, which corresponds to this number over here, and 100, which corresponds to this number over here. So all we have to do is change that, and let's go down to 50. We can see there's no data below 50, and we're not really interested in that, because we can kind of see that sales when the weather's pretty cold in beer is not going to be that great. So we'll set the minimum at 50, and we'll click and then we'll just actually tab into another box, and then we can close that, and you can see now that we have a nice chart, a scatter chart, which shows a correlation between the temperature on this x-axis, horizontal axis, and the amount of beer being sold on the vertical or y-axis. So that's pretty interesting, and it appears to be somewhat linear, and we can kind of make a prediction. So you certainly could eyeball it and draw a line through here. In fact, I could easily do that by clicking Insert and then insert a line and actually go from here and kind of draw a line of my own and eyeball it, and okay, we got a line. Pretty close, and we can make that line pretty big. And so now we have an eyeball, and we can kind of play around and move that line to where we want. And that's maybe good enough. However, there's a more rigorous approach called a statistical analysis approach, and where we can add a trend line. And Excel does a great job with that. So how to do that, we right click on any one of these data points. So you point to one of these data points, right click it, and you can see we have add a trend line. Little window opens up on the right hand side, and this is now Excel has added a trend line of its own based upon certain principles. And for a linear trend line, it uses the least squares method, which essentially minimizes the vertical distance, if you will, from all the points, a square of the vertical distance actually of all the points. And so by minimizing that, it's going to get a best fit, if you will. And so that's pretty cool. What we do before we get out of this, we're going to actually click on these two boxes down here. It says display the equation on the chart and display the r squared value on the chart. So I'm going to just take these two guys and move them over here, and I'm going to go home and I'm going to make them a little bit bigger so we can see that. I'm going to bold them out, and then I can close this out. And so you now see that we have a least squares line, a linear analysis of the data, and it's using the equation of a straight line, which we used before in our previous lesson. Y is equal to mx plus b. And so what Excel has done is created a line with a slope of 438.44 and a y-intercept of minus 23,535. And Excel says that given this data, this particular line will minimize the difference, if you will, the vertical distance from that line. And so it'll go through those iterations, create that. And that's really great. And so we can actually say, if we wanted to predict the sales, what the sales might be on a 75-degree day. So we have no data for 75. Anything from 73 to about 72 looks like it is empty. So in fact, this would be a good approximation. I mean, based upon the data, we could say, wow, it might be flat here, because you can see if you look at these points, it's pretty flat. And we might be overestimating the sales, or which can lead us to having too much beer on inventory and might lead to some spoilage, or again bringing too many people on board and having high labor costs when it's not really necessary. So again, this is a least squared method on a linear equation, and we can plug that information in there. And if in fact, if we were to plug that information in there, we would end up, if we plugged in 75 degrees, we would end up with a sales of $9,348. Now you can eyeball that by just inserting a line, for example. So let's see what we can do if we eyeball. So we insert a line, we're actually going to go with an arrow. And so what we would actually do is go down here to 75, and I'm going to hold my shift key down and draw up this arrow, and we can see that's the intersection of our line with that. And then I'm actually going to make this a red arrow and make it a little bit fatter, if you will. And then let me zoom in here a little bit. We can then insert another line going from this point here, and once again I hold my shift key down. And again, holding the shift key down makes the lines stay either horizontal or perpendicular. You can see if I move my mouse up here, it's going to go in at 45-degree angles only. And here now it stays parallel. And again, I can then, if I want, just go ahead and copy this format. Or actually, I'll just go into here and format it the same way with format, shape, outline, red, format, weight, down to here. And so I could come up 75 degrees, see where that line intercepts that point, and then read to the left. And you can see that is about 9,348. I'm not that good, so I would say 9,350 would be close enough for eyeballing. So that's how you would do that. And that might be well and sufficient. One needs to be careful when we're extrapolating, because this is called extrapolating that data. And so if we get down to the edges, our model might break down. For example, it would say that at 50, somewhere around 53 or 54 degrees, we would have 0 sales, and that's probably not accurate. We wouldn't have great number of sales. You can see as the temperature goes down, and it might be too cold, people won't be drinking beer, but you'll always have somebody to drink a little bit. But obviously the number is going to be very close to 0, and one might say, well, what happens when the temperature goes to 110 or even 120 degrees? Wow, we're going to sell $30,000 worth of beer? Probably not. One would argue that if the temperature gets really, really hot, people won't even bother going to the ball game, and in fact, sales would plunge. So you want to be careful about extrapolating data beyond the models. But certainly within the data points, it's reasonable to assume that we have a pretty good model. Now let's draw our attention to this this r squared value. So in fact, with r squared, it's an indication of correlation. So the better the data is correlated, the closer that number comes to 1. And so if r squared is equal to 1, we would say the data is perfectly correlated. In this case, r squared is less than 0.9, which means it's correlated somewhat, but not very, very strong. Generally, one would want to see r squareds of around 0.9 or higher to indicate a very strong correlation. So in fact, let's make a copy of this and save this, because you'll see why. I'm going to go move or copy, create a copy, and we're just going to leave there. And you see now I have beer sales too. So this is beer sales. And I'm going to rename this beer sales linear, because that's a linear correlation. Now let's go to our beer sales 2, and we're going to rename that beer sales power, because we can go back and take a look and use a different analysis. So we're going to format our trend line again. So instead of a linear, we're going to use a power function. So what is a power function? It uses a formula of this type: y is equal to some multiple of x raised to some power. And again, Excel will do a number of iterations to develop a line that minimizes the error factor, if you will. And you can see this actually mimics the data a little bit more closely. And in fact, if you look at our r squared correlation factor, it's 0.916, or almost 0.9, it would be 0.92 if you rounded off to 2 decimal places, which is much stronger correlation than the 0.87. So in fact, this might be a better model, and you can see if that's the case, our predicted sales would be down to here. And we'd have to reduce our sales. In fact, if you plug the value into the equation, we get predicted sales of $8,567 at a 75 degree. So 885 versus 98, that's almost $800 difference in sales. So pretty big difference. So this would tend to give us a lower forecast. And then so we'll make this, make a copy of this. And now we're going to do one more. And this is going to be your sales exponential. And we're going to use an exponential model to predict the sales. And how do we do that? We go to Format Trendline. So instead of a power, we're going to use an exponential function. And you can see with an exponential function, we get a little bit less of a correlation factor, 0.908, still better than our linear model, and this would reduce our, would change our forecast even more. We reduce our forecast even more. And if we look right across, our sales for an exponential model would be about 8122 in sales. So you can say each model will give you a slightly different answer, and you would have to use your own experience or judgment. But again, the two models, the exponential and the power correlation, would indicate that it would they offer a better fit. So up to you. Do you want to take a chance and not have enough beer on hand and risk losing revenue, or would you rather have a little bit too much beer on hand and knowing that you could probably sell it anyway? So most business people will opt to have a little bit more on hand than necessary. They'd rather have a little excess than run out, because if you run out, you've lost money. Whereas if you have too much on hand, you may not have really lost money. You just may have delayed your sales, and you can push them forward a little bit. So there you have it. How to use data, analyze data, create a scatter chart, analyze the data to see what, if any, the trends are answering. So thanks for watching. Hope you enjoy this lesson.